As for this case, it will be grams per centimeter cube. In this case, because we're using grams, it's actually possible. You can check your textbook if you have it, right? You can have either grams per centimeter cube or so kg per centimeter cube. Sorry, grams per centimeter cube or kilograms per meter cube. In this case, this is for small objects, right? This is for small objects, and this is of course for bigger objects, larger objects, right? For example, a car or something like that in kilograms. In this case, we'd use it for small objects like a stone. Can use grams per centimeter cube. All right, so if you have all of these, there's nothing stopping you from getting a full marks. All right, remember that your density is equal to mv. So for the calculations, to get your calculations mark, ensure that you show one. You can show an example of one of these. So just show this. Just write this off and just show it back down. So show an example of you calculating density. That's how you get your calculations performed correctly. To get your correct formulas and units present, of course, you will have for your final thing here, you should have GCM per kilogram per centimeter cube. This is for your final mark here. Now, as you said, the moderator requires you to have certain things. For example, your conclusion, right? You want to ensure that you go back and ensure that you have your conclusion matches up to your aim. Now, to determine the density of two irregular shaped objects or two irregular shaped solids, your conclusion to say something like the density of object A is so, and the density of object B is this. That's your mark, or that is your conclusion. And of course, you have your limitations, your sources of error, and your precautions. You can think about these. All right. You can also discuss them in your group. I just wanted you to get a better understanding of them, right? For the first lab. So include these into your labs. All right. So is everything clear on lab 2?
Yes, sir.
All right. Yeah. So you can discuss these various things in the group. You can discuss source of error, limitations in your, I don't know if you want to make a WhatsApp group with each other or whatever, and discuss these things. Or you can come to me. You can send a message in the group and say, sir, what about this limitation for this particular lab? And I can look at it and then we come up with that. Now for this third lab now, lab 3. Mr. Aldrich, could you tell me what corrections did you get for this one?
Only
the corrections, as in the past tense.
All right, past tense.
Yeah, only that one.
All right, so Mr. Nigel, did you get any corrections for this lab as well?
So, sir, the irregular shape, we support them in the book.
Right, so those irregular shapes, you will put them in the books, right? Where it says results, you will place them there.
John.
Oh, you lose it? You lost it?
Yeah, there's something there.
All right, so remember I said that you should have these secured, right? I specifically said secure them in your life, basically. All right, so of course, let me see here. So for Mr.
If we lose one, we can't just make another one.
All right, why are you asking me that? To my knowledge, you don't want to lose it, right? Don't lose it. That's all I have to say. All right. So Mr. Blakey Blacks, everything is okay for you. 3 holes were punched.
Repeat.
Everything is okay with the method so far for you. So you should get your 3 marks. Listen, guys, you don't want to give away these 3 marks, right? Come on. Really? These 3 marks, just write it in past tense. Just rewrite the method in past tense. That's it. That's it. That's really it for that 3 marks. The second one, the recorded the object, the what was observed. Now this can be either in your discussion, or this can be as a separate observation, right? You can have something like observation here, right? You can have a little mark saying observation. I don't know if you want to do that, but just ensure that this is there. This could be either here, or it can be in a discussion. It doesn't matter to me. Ensure that you have it, right? This can be in a discussion. So you record what was observed. What exactly was observed from this lab? What did you observe? You observed that those lines, the 3 lines, what happened to the 3 lines?
So it determined the center of gravity.
All right, so we know that it determines the center of gravity, right? That is good, but what happened? What did the 3 lines, did they intersect or they did not intersect?
They intersect.
Exactly, so you can state in your discussion to get this particular mark, these 2 marks, you can state it in your discussion that it was observed that when doing the experiment, right, and drawing the lines, we saw, or I saw, or it was observed, right? Don't use I and we. All right, use it in the third person. It was observed that these 3 lines from the 3 holes all intersected. Then now, to get this mark, report the results and give proper explanation. But this 3 mark, all you have to say for that 3 mark is that these 3 lines that intersected in a new sentence, these 3 lines represented the center of gravity. And you want to answer more of these questions, right? To back up your statement. To back up your statement, you want to use more of these questions, right? So you can state, just explain, give a good explanation that these 3 lines, what I'm looking for, the fact that these 3 lines intersected, right? And the second part is that the intersection of that particular point represents your center of gravity. That is what I'm looking for. Of course, you would get 2 out of 3, right? Give more explanation to get the full 3 marks.
Yes.
All right. And for these questions, this can help you define the center of gravity. Where does the center of gravity act for a regular object? So you can say that for a regular object, all right, it acts at the geometrical center. But for the irregular object, right, you would have to do this experiment. When was the irregular? The irregular laminar balance, unbalance. All right, so we can take on some of these questions. All right, as I said, these are just a guide. I can leave that one. Where does the center of gravity act for an irregular shaped object? All right, for an irregular shaped object. All right. All right, so use these questions instead. So take a picture of these and send a picture of these and post them in the group as well. All right.
Yes, sir.
All right, so do that. All right, good. Thank you for that confirmation there. All right, so these are updated questions, right? Just use these to help you answer the questions. And then, as I said, ensure that you state that wherever the lines intersect, that is your center of gravity. That's the 3 marks right there. Come on. All right, the conclusion appropriate to the aim. Now you get a mark for this. I'm making it more clear. Conclusion, ensure that you go back to your aim of the lab. The aim to determine the center of gravity of an irregular shaped body. You would say that the aim for your conclusion, conclusion, you want to bring it back to the aim. So therefore, for your conclusion, you could say something like that. Like the center of gravity for an irregular shaped object is at the point at which these lines intersect. These three lines from hole 1, hole 2, and hole 3 intersect. That's their center of gravity. All right, and then you get a mark for your conclusion. So is this, of course, you have a source of error, limitation, and precaution. So you want to include your limitations. As I said, the moderator is looking out for these as well, not just me, the person who a representative from CSEC, they will be looking out for these particular things. Limitations, source of errors, and precaution. You can have one for each. One limitations, one precaution, one source of error. All right, you can think about them and then let me hear them in the group. All right.
Source of error, precaution.
These should be for each lab. This is an ORR lab. So this lab stresses observation. So therefore, you should, this is an ORR lab. This means observations, recording results, I think.
So
I should think
which
so.
number lab this?
This is lab 3.
Last all are going on. Oh, all right, sir.
All right. So ensure you go through these as well.
You did do it?
Yeah, I'm seeing it here. Were you asking me if I did it?
No, as in over in general.
All right.
Yeah, no.
So are we clear on this?
Yes.
Yeah, so remember your results here. Remember, you can have your observations here or in your discussion. I'm just looking for your observations because it's an ORR lab. It's an observation lab. This means observation. All right. Moving on to the next one. No, this is not it. This is pendulum. Let me see, which is the next step again. We will do pendulum next week. All right, so the next one was radioactivity. Lab 4 is actually radioactivity. Let me see if I can find it. All right, here we go. All right, so let me see. Okay, good. Mr. Aldre, could you let me know your corrections? All right, let me hear your corrections.
No corrections for the method.
All right, what are the corrections? Is there any corrections for this?
For the table, sir?
Yeah. All right, what is seen there?
The title.
All right, so of course, come on. They're giving away marks for the title. Any other corrections?
No, that's just.
All right, so remember that we changed some of the readings. I am seeing that you did that here, Mr. Blake. Any corrections, Mr. Nigel, for this lab?
What is half-life? What is? I don't remember the lab.
Mr. Nigel,
Half-life.
Did you get any corrections?
I did something more radioactive decay.
Yeah, right. All right, so let me set the chat. All right, so no, sir. Okay, good. So let's go down to our thing here. All right, so for this now, this is our the mark scheme. I'm hearing some feedback. All right, so procedure. If you write it in past tense and it is in correct sequence, you have 3 marks already. Very easy stuff. Then your table should be neat as well. Neat and with headings and so forth. Right, your graph now, you should have a graph for this. So check your mark scheme. And also your method states that plot a graph of volume against time. So if you don't draw a graph, you lose 4 marks. So the maximum you could get is 6. If you don't draw a graph, 4 marks. You just lose 4 marks a while ago.
All right, so how the graph go again?
The graph is volume against time. So what would be on your y-axis?
Volume.
Exactly. So always the first one that comes up, the first one that pops up, that is your y.
Yeah, that's it.
So
So,
y-axis volume,
hold on a
x-axis
second.
time. And it should look something like this, right? Look something like this based on the results.
So, man, that's-
But you don't understand.
isn't it? If we put in every coordinate on the y and the x-axis, then we drop in the point them, sir. That's
All right,
right.
so this is a graph. Let's say you have volume here. Right, I went through this already, you know, and you have time.
Draw one line.
So it starts at 0. All right, say that let's look on the volume first. So the volume could look something like the axis could look something like this: 10, 20, 30, 40, 50. And then your time, say it's 0, 10, and 13, and 15, whatever, going down. You could have 10, 20, 30, 40. Or it depends on what type of values you have. And let me use your values, Mr. Blake. Use your values. So I'm seeing, okay. I am seeing 32.
30.
I'm seeing, let me erase this as well. I am seeing 0, then 32, 32, then 37, right, then 40, going right down to 139. Right, I won't write each of these. No, you have 0, and then the last value is 139, approximately 40. So let's place, say 150 here. So you can go up by 20, or it depends. You can go up by, even 20, it can go by 20,
Yes,
right?
sir.
So 20, 40, 60, 80, right? Going up. So I know not enough space is here, but essentially your first value would be 30. So it'll be between here and your first reading is at 5. So your first reading, right? Let me see. No. You have 0, 50, then 45, which should be here, at 30. Right?
Yes, sir.
And then the next reading, 37 will be here, and then 40 going up. 40 will be here. And then let me see, 40 here. Then 30,
5.
35, yeah, 35. Right? So it would come down, essentially look something like this.
Oh, yes, sir. It's a slope.
Right?
Yes,
Look
sir.
something like this, all right? So you have an axis for the different sections, and then you plot a graph to the appropriate section. So is that clear?
Yes, sir.
All right. So that is for the graph. And of course, you will have your title always, and you write out volume. Don't just have V like I have. Write out volume or write out time. All right. And what else? Are we missing out anything? Title, labeled axes, correctly plotted. That's it, and you get 4 marks. And of course, you have a discussion. And you answer as much questions as you possibly can, right? Just do, and then the moderator is looking for your conclusion, your source of error, precaution, and the simple stuff. Just have one precaution, one source of error, one limitation. When I was doing CSEC, I had to come up with 3 of each. All right, my teacher had me do 3. So 3 precaution, 3 source of error, 3 limitations.
Yeah.
Think about that. All right.
Yes, sir.
Yeah. So I'm only requiring you to do 1. All right. Yeah. So that's it for that. Any more questions on lab 3?
Yes, sir.
Yeah.
Yes, sir. Precaution.
Right.
3, repeat them again.
Just 1 precaution, 1 limitation, and 1 source of error. Just 1.
Okay. So then will be a part of the discussion, sir.
No, you would have a separate section, right? You would have a separate section for let me see, where's my pen? I have a separate section, the limitation, then blah blah blah. Source of error. Source of error. Right? Whatever, and then you will have your precautions. So you would come up with these based on your experiment. All right, and you remember you can discuss these with your other classmates. All right. The aim of the way that you will get over this, the way that you get over this hurdle, is just working together. All right. That is the only way to get through this. Teamwork. So don't copy, but you can discuss your ideas with others. Now, lab 5, I know it's saying lab 7, right? But it's actually lab 5. Were there any corrections, Mr. Hamilton, for lab 5? Were there any corrections? Were there any corrections, Mr. Aldrich?
Yes, sir.
What corrections did you see?
The meter rule was placed at a point, a pivot.
For lab 5?
Yes.
What's the lab 5?
No. Yes. Yes, sir. The subject mass was determined for the first.
All right. Yeah, so of course you use past tense, right? The subject mass was determined by using a kilogram scale, or I think I changed this. Wait, 1 second. All right. Let me check something here. Come on. Love money was. All right. This is it, I believe.
Oh man, you're kidding.
Your lab 5 is poor, right? So determine the subject mass by using what again? What correction did you see?
subject mass was determined. That's the element.
All right, so the subject mass was determined by using, I don't, let's change this to um top pan balance. That's what we actually use in the lab. All right, so make this change as well. Just write it down in your manual. All right, top pan balance. I'll write it down in the draft book, right?
So
That
you
is,
know, may I take a picture?
all right. Now the second part would be, right, so a kilogram, a top pan balance was used to measure the mass of the subject, right? You can also state that. The second one would be the subject's weight was calculated by using that. So that is good. I am seeing that is good here. Now for your title, right? I am stop writing title for you. I have stopped writing title for you. So you should come up with your titles for the various sections here, right? And for the calculations now, right? So ensure that you have subject A, subject B, or whether we use subject X, subject Y, anyone that we use. All right. Where is it? Doesn't matter what type of. This is manipulated and measurements, lab measurements and manipulation, right? So therefore, you're going to have calculations in this particular one. Now, if you have your procedure in sequence and in past tense as well, not a problem, 3 marks. If you have your table neat with headings and values and so forth, not a problem, 2 marks. That's 5 already. If your calculations are performed correctly, right? So you will show one of these calculations, right? You show one of these calculations. How? And I'm seeing that Mr. Right, I'm seeing that Mr. Blake here did a calculation. So he would have gotten his 2 marks, or what? Look at this, 3 marks. And I am also seeing his formulas that you all have to do is just write back these formulas. And then you get back your mark for relevant formulas present. Calculations performed correctly, 3 marks. Relevant formulas present, 2 marks. That's a 10 marks there. And then required by CSEC, you should have your limitations, source of errors, and precautions as well.
So, sir,
All right. Yeah, so that, as I said, the moderator will be looking out for these. These are very essential when presenting or communicating results from a lab experiment. You should say what you did as the precautions to ensure that your lab was successful, and your limitations, the grade. Go ahead.
We can discuss it about this lab here, sir.
Right, you should also have a discussion. What do you want to discuss about it?
The limitation, sir, and this one kind of different.
All right, no problem. We would have to, when the time runs out, we'd have to pause again and then come back. So, for example, a limitation.
Yeah. Yes, sir.
All right, what would be a limitation here for this lab?
No.
Let's look back on the experiment.
This, like the amount of steps, then, sir, where they have the different.
The amount of steps that would be there to climb. No, that would be a limitation. What could affect your results that you're not able to control?
Okay.
What are you not able to control? Think about it.
Sir.
Yeah.
The person's like if the person healthy.
The speed at which the person.
All right, so I'm hearing two wonderful points coming out. I'm hearing two wonderful points. So, I believe Mr. I didn't hear the voice properly. The first one, about healthy. Who said
Address
it again? Yeah, Aldre said healthy.
Yes, sir.
All right, so the subject,
health, analyze.
the
Yes,
subject,
sir.
the subject health, right, could cause the subject's health during the experiment. During experiment, let's see. What about the subject health?
Like
Subjects.
if the person have one foot injury, sir.
All right. So the subject's health during experiment. For example, an injury could affect the results. What else? I heard Mr. Blake with one.
The respiratory condition.
I also
Either
respect.
lead
Right,
back
that's a good one. That's a good one. That's a good one.
respiration.
You were saying, Mr. Blake?
No, me just say that still lead back the health. I say the rate at which the person is able to climb the steps.
Exactly.
Speed.
So the speed of the person could change while doing the experiment. Right? That's another limitation. The speed. So we as experimenters are not able to control that. We're not able to tell the person to go to climb the stairs at a certain height.
Yes,
right?
sir.
So while they could be moving quickly at the beginning of the experiment, but as they reach the top of the stairs, they get tired and they slightly slow down. That could affect. We are assuming that the speed of the subject is the same, right?
Yes,
so
but
the speed of the
like
object could decrease during the experiment.
Yes, sir. But you can differentiate between these, sir. So
exactly.
Like,
so we're not able to change that during the experiment. No experiment. Right? So you can come up with more of these, right? Or write them down. You write them down already? Or make note of them already?
Yes, sir.
Or just snap a picture or something.
Yeah. Funny.
All right.
Yes.
No, for source of error. What do you think for source of error?
As in using the wrong formula for calculation.
Source of
So if
error.
the formula have an impact, yes, of the results you get from the calculation.
Not really.
Right.
Right. Let's try again. While doing the experiment, what mistake could we have made while doing the experiment? What we did? What did we do? We took the time, right?
Yes, sir.
Stopwatch late or early.
Exactly. So we usually call it reaction time. Whenever we're talking about stopwatch, guys, just say reaction time. Reaction time in starting
I wish love this.
and stopping the stopwatch.
Yes.
Right? Which other could we have? Which other source of error could we have?
Sir, if like we have calculated the person's weight and we have a wrong
Units.
yes, sir.
The wrong unit.
Let me see. All right.
Yeah.
Which other one could we have?
Would you do?
So mainly starting and stopping the stopwatch. Right. We could not determine when the person reaches the stop step. Right. It was difficult, right?
Yes, sir.
Yes, sir.
So it is difficult to determine when the person reaches the top step. So these are some examples when the person reaches
sir.
reaches the top step. Person reaches the top step. All right, so that is the last. This is the last lab. I'll do the source of error 4, right?
Right.
These are some examples of source of error.
Yes, sir.
So you snap a picture of these already?
Yes, sir.
All right. And for precaution, we have less than a minute on this one again. What are some precautions that we took?
We ensure, sir, everybody
Mm-hmm.
start steps from the bottom of the step them, sir. So when I make nobody climb here, no different no different. I mean that's a no. Everybody start. It's like nobody not start climbing steps in the middle of the steps, sir, or from top to bottom, sir. So I make sure everybody start from foot of the
Okay.
step.
So ensure that all subjects started at the same point.
Yes, sir.
All right. Which other one could we have? That's a good one.
We make sure say, wow, I never did that. No, sir, no. Is it? We make sure so none of them never exhausted, sir, while them are climbing steps.
Exactly. So you ensure that the subjects are let's say ensure that they're okay. I don't know how can I say that in science